research you're performing? Okay, so I am a cellular neurobiologist, and I don't exactly do chemistry. And I mostly work with human embryonic stem cells, and the focus of my research is to find treatments against neurodegenerative disorders like Parkinson's and Alzheimer's disease. So what I work on differentiating pluripotent stem cells into distinct type of neurons that are degenerative in these diseases.
So as a lecturer, I don't have a research group here. Most of my effort goes towards teaching, but I do have a group of students who are working with me on developing new lab experiments. So this semester we've got 3 grad students and I think it might be 15 undergraduates who are working on a project with me to develop new experiments for the Chem 1 and Chem 4 classes. And we're actually pilot testing some of them starting next week, so that's pretty exciting. Some of you are probably in that class. And then I also spend some of my time developing new experiments for the organic class as well.
Okay, so my field of research is, I still have a very small research group. It's just a couple of people right now, like between 5 and 10 if I count the undergraduates in. And we're mostly focused on developing new synthetic tools and new materials for electronic applications. So when it comes to the broader field of organic soft materials, which include molecular wires, which include molecular transistors for computing and so on. So but let's say like 80% of the work is still basically organic synthesis and device modification.
How did you get to where you are right now? Well, we start by going to grad school. So I majored in cellular neurobiology. I entered a graduate partnership program at NIH and Johns Hopkins. So I did my graduate studies there, and so I pretty much took my courses at Hopkins and did my research at NIH. So I was intrigued to continue doing research in that field. So I joined the Schaefer lab to do a postdoc in neurobiology / bioengineering.
So I did my undergraduate studies in chemistry and medicinal chemistry. They were actually 2 separate degrees for unknown reasons at University of Buffalo. I actually switched into the chemistry major during my sophomore year when I took organic chemistry. I was pre-med, I was a math major, I was a pre-pharmacy major, I was a biology major. I kind of went through a whole list of them during my first year until I took organic chemistry and I was like, oh, this is what I really like doing. So at that point, I still had no idea what kind of career I would want in that, but I knew that I was more interested in those classes, and so that seemed like a good reason to switch my major to that. When I finished that, one of the things I think that influenced my decision was, as far as where to go next, was I did a summer internship at Pfizer, and I found that really fascinating. I was in the medicinal chemistry, designing new molecules and that sort of thing department, and I was working on this little methodology project, so trying to figure out what was going on in this one reaction that they had run, and then they weren't actually using it to make a drug anymore, but it was, hey, what went on here when it didn't do what we expected? So I thought that was really cool, and I came to grad school here at Berkeley, partly because I wanted to, my goal at that point was to become a medicinal chemist, to go work at a pharma company when I was finished with my PhD. And when I got here, I ended up teaching a few times, and I found that I really liked that even better than doing research. So when I graduated with my PhD several years ago, I was lucky enough that a position opened up in the department and I've been here. So I've been here ever since.
So the question was how I got where I am right now, right? So I grew up moving all over the place, so the time up to basically my undergrad is very inconsistent. And I did my undergrads in Germany at one of the older universities in Germany, in Heidelberg, and the system there is very, very different to what you're experiencing here. It's essentially you're thrown into the deep end of the pool and you're and it's a very, very rough selection process. And they're changing the system now. It's much more like the American system now. But at the time that I did my undergrads, it was like a rude awakening that that is really what college is. And after I mastered that, I decided that Heidelberg was a little bit too small for me, and I went to Switzerland, to the University, to the Swiss Federal Institute of Technology in Zurich. And this is a little bit run like a mix between a research university and a state-funded science institute. So you can imagine it a little bit like a mix between LBNL and the University of Berkeley. So the teaching load was not that high there as a graduate student, but it was mostly focused on research. And I finished my PhD there in 3.5 years, and I decided to switch fields completely from what I'd been doing before. I've worked on medicinal chemistry, essentially, or supramolecular chemistry, a lot with proteins and enzymes, and the binding and the affinity of ligands to enzymes, and how to measure that, for example. And then I moved into material science in my postdoc with the idea, basically, not really intentional, but my boss at that time said, like, you're not going to do anything that is related to what you've done before. You have to do something completely different if you want a faculty position later. And it was one of the best advices that I ever got. And I went to Columbia University in New York, and I worked in material science, much more closely related to what I'm doing right now. And after that, basically, it was a big lottery. Getting a job as a faculty anywhere in the world is highly unpredictable. It's a little bit like dating. You really don't know if it's going to work out. But you're kind of in a position where you have to find a job. And if you're persistent enough, eventually, some of us are lucky and get the position that we want. But if you had asked me if I'm going to be here a year ago, I would probably not have been able to answer that question. I could have been anywhere. I could have ended up anywhere. So Berkeley as a goal was never really my goal. I was very, very fortunate to end up here, but I cannot say that was planned or I had that perspective in mind when I started applying for jobs. I applied for 60 positions, so I would have taken any of them.
So what do you feel are very important skills in your career?
So, I think most importantly, you have to in order to be able to do research, you have to be curious, and you have to be persistent. And sometimes you can spend months or even years on a project that does not end up giving you the results you were hoping for. So there are ways that you can kind of compensate for that. In developmental biology, mostly, you run several projects at the same time, and you're hoping that one of them will actually end up giving you the results you're looking for. So I think most importantly, you have to be persistent, you have to be curious, and you have to truly love what you do. Otherwise, you're gonna.
I would say that for teaching specifically in your career, obviously clear communication skills is really high on the list. And being pretty well organized, especially when you end up with very large class sizes and classes where there's multiple sections and that sort of thing, and organization is pretty key. But actually you stole the curiosity and just really being excited about what you're doing, because if you're not excited about what you're doing, you're going to hate your job anyway, like even if you have the skills that you need to be successful at it. So that really wanting to learn more about your field, even when you've been teaching it for a few years, being really excited when somebody asks you a question that you don't know the answer to in class, even if that's embarrassing. That element of always wanting to learn more.
An analytical mind always helps.
I mean, there's not a lot to add to this. I mean, I can just emphasize it again. One of the big things you need is patience, because that's often a misunderstanding. Science doesn't happen in a week or so. In results don't show up in a week. It takes years, and it takes a lot of work. And it takes an endless string of disappointments until you hit one thing that works. And it's kind of a mentality that you have to kind of develop, that there can be weeks where basically nothing works. There can be months where you basically end up, if you look back at the work you did, nothing actually changed. And then there can be a day or two that basically make or break a year. So you have to develop tools to cope with that. Otherwise, it's going to be a very, very frustrating work life. You have to be passionate about what you do. So this is one of the things that I usually emphasize a lot. I mean, what are you passionate about? Why do you choose science? What is the reason that you want or that you plan to go in this career? And it's different for everybody. Every individual has different plans and different passions. For me, it's kind of, I'm excited every time that I go to the lab and I can do something that nobody else has done before. That's a super exciting thing for me. If I go back to the lab, I can easily make a molecule that the world has not seen before within a couple of hours. And that's something that is, I think, almost unique about the chemistry, physics, biology, that you have these tools at hand to basically walk rounds that have never been walked before. So I don't want to say it's like kind of this explorer idea of sailing the world or the great seas to discover new lands. That's a little bit too poetic, but I think it goes in the same direction, or it's the same mentality that makes you like the work that you're doing. And apart from that, especially in chemistry, so because that is my field, it's not purely a work, a theoretical work. So there's a lot of day-to-day labor involved in it. You have to be good with your hands. You don't just have to be bright and understand what's going on, but you have, in order to be successful in the field that I'm working in, you have to have the skill to do stuff with your hands. And this is something that you have to train. This is nothing that comes automatically to you. It's almost like carpentry. You have to learn the tools of the business. And if you enjoy that, if that's pleasurable, then it almost doesn't feel really like work. Like when I come here to university, it doesn't really feel like work. I'm fortunate that it feels like your leisure time. You do science, and that's your passion. And it does not feel like you do this because you get a paycheck at the end of the month. In science, sadly enough, you don't make that much money. It's a sad truth.
So how would you describe your typical day?
Okay, so it's highly variable, but I'll try to pick a real typical one. And I usually walk into lab wondering what has happened to all my neurons and all my cells in culture overnight. So the first thing I do, I check on my cultures to confirm that they're doing what they are supposed to be doing. And I usually spend 2 to 3 hours in the tissue culture where I do my cell work. And afterwards, I spend most of my time reading papers, designing other experiments, writing manuscripts that are to be submitted, and having meetings with collaborators, people in the lab that I'm working with, and my undergrads, to make sure that they understand what they're doing in the project and everything as well. So that's a fairly typical day.
So my days, on the days that I'm teaching lecture, that's first thing in the morning. And then I have some time set aside where I have time right after lecture to kind of follow up on anything that came up. So looking up, if I was asked a question and I don't know the answer to, that's the time that I can go look for more information or go find somebody I can talk to about it. Or if there's a student brought me a problem that they need And then I spend a decent amount of my time also meeting either with the graduate students who are teaching the lab sections for my class, or meeting with the graduate students and undergraduates who are working on developing new experiments to sit down and brainstorm ideas with them and make progress on making sure everybody feels like they know where we're going with those projects. So mostly trying to get to open lines of communication between all the people who are working with me. That's most of my time. I'm going to meetings. There's always meetings.
A typical day. Well, it's hard for me to say because I'm still in the transition phase where I'm building up my lab, so the days can be very, very different. But roughly, I would say that it's divided in thirds. So 1/3 of my workload or my time is devoted to teaching, essentially. So as you said already, like preparing classes, writing exams, grading exams, problem sets. All that is associated with that, office hours. So that's about 1/3 of the work that I'm doing. Then another 1/3 is actually dedicated to mentoring the graduate students and postdocs, and that can take the form of group meetings, that can take the form of individual meetings with collaborators. And it's quite a lot of time that is basically one-on-one discussions about science, trying to fix problems, trying to work around problems. At this stage, I'm still pretty involved in the work that is going on in the lab on a day-to-day basis. So I currently only have one postdoc, and if there's a problem to be solved and they can't work their way around it themselves, it's usually they ask me, and I try to help as much as I can. Most of the time I just have stupid ideas. But the third part is essentially what is a little bit unique to the job as a faculty is that suddenly you're responsible for getting money in. And that takes a lot of your time. So it's not just the fact that you have to write grants and that you have to come up with ideas, but a lot of bureaucracy is associated with that in managing that. Yeah. So if you look at a research lab in chemistry, and I think in biology is probably the same, if you look at the organization, it's a little bit like a small startup company. And you're responsible for your employees, which are postdocs or graduate students, and you have to make sure that they basically can pay their rent at the end of the month. You have to make sure that they have health insurance and all that stuff. Ultimately, you're responsible for that. And that is a lot of paperwork that you have to go through on a day-to-day basis. It's something that I had underestimated, actually, to say that frankly. I thought it was not going to be that bad, but it takes a lot of my time right now. So between these three, usually a day for me starts around 6. I usually arrive at 6 in my office, and then the day goes on with meetings. Twice a week we have faculty meetings, and then if you're on one of these committees that are responsible for the safety of the department or something like that, that's additional time that goes into organization. And I try to get to end the day usually at 9 or so. So that's usually the time that I spend.
So what is one of your most memorable experiences in this career? And is that for your lab this time?
The most memorable experiences, well, I think it was actually getting my PhD. And I had like these big expectations that suddenly, well, you pass the exam and suddenly you're a PhD, and I thought it would feel different. It was kind of a weird disappointment that when the faculty that were on the committee to test you basically shook your hand and said, congratulations, Dr. Fisher, and you're just like, that doesn't feel any different than that. So that was kind of I don't want to say a rude awakening, but I don't know what my expectations were really. It was kind of like suddenly, yes, you are now a PhD. But it didn't feel any different, and you didn't feel any wiser or smarter or better or anything. But it was something that you actually worked for a long time, and if you look back, you know that you struggled for a long time to get to that stage. At that stage, I thought it would be like a huge step, and we would all come in at one point, and you say, yes, it did. But it wasn't really. It was like a gradual thing that you grow into that. And I think it's more like the process of going through this program, a graduate program, rather than that final exam at the end. That just terminates it essentially. But your personal development takes place during these years that you spent in graduate school. So I think that overall experience, I think is very, very valuable, and I cherish it a lot. The ending was a little bit disappointing. I thought there was going to be something bigger, but I mean, maybe it's different for you. I don't know.
Well, I was going to say, one of my most memorable experiences, I told you I wasn't even thinking about teaching as a career when I came here as a graduate student. And so I taught lab sections for the 3 DeCal class, the organic lab class, a couple of times, and I said, no, I really wanted to try something a little bit different, because my favorite part of this is office hours. So I asked to teach a review session. So I was teaching review sessions for the 3A class during my 3rd year of graduate school. And I distinctly remember one day, these were weekly reviews, I distinctly remember one day coming out of the review session, it was like 9:30 at night, I was supposed to have ended at 8, and it just went, like, people had really good questions, and some people left, and we just kept going, and I was just really into it and really excited about it, and then as everybody was leaving, and I was going back up to the lab to pack up my stuff, I was looking at my lab notebook sitting there, and I'm like, nothing's been working in my research. I wasted 3 months trying the same thing that doesn't change. And I realized that I was way more excited about the teaching than I was about doing the research. It's not that I didn't like the research, and it's not that I didn't have points of time times when the research went well. But that realization that the teaching was what was really getting me excited about being here was kind of a pivotal moment for me. And that's when I started looking around and saying, well, maybe I don't want to go work for a pharmaceutical company. Maybe I want a job like Steve Peterson has. Steve Peterson's been a lecturer here for a very long time. So I kind of identified that the lecturer position as sort of my dream job, because I wouldn't have to be looking for grants, and it's something I could focus all of my time on teaching. And that was kind of the moment in time when that was really clarified.
Okay, so I certainly did enjoy getting my PhD. I had a requirement of 4 first author publications for my PhD. So when I was lucky enough to pull that off, and so it was a gratifying experience for that man to shake your hand and tell you that Dr. Vazim, you got your PhD. But I'm going to talk to you a little bit about what I experienced during grad school that has been truly memorable. So I did developmental biology. I turned human embryonic stem cells into neurons, which I find extremely fascinating. So the first time that I tried to do this, maybe I had 20, 30 million cells, and there was 1 neuron in that culture. Maybe for a few minutes there, I thought maybe this is not for me. My background was, I got my master's in biotechnical engineering. So I thought, I'm not a biologist, I should go back to engineering. After a while, a few months later, more successful experiments, I just find it extremely fascinating to be a part of seeing, I'm not a very religious person, but God or whoever it is work. It's fascinating to look at these cells interacting with each other and understanding the complexity of the network and how the human brain works. So for me, every day, when I think about the amazing things that I have been able to learn and experience, that is truly fascinating.
So starting from the left again, how would you suggest for students that have research positions in your lab?
So the easiest way is actually to just contact me or contact the faculty after a lecture or just knock on the door. Usually that is the easiest way. I have to say in the chemistry department generally, we have many more requests in research than we actually have space. So it's not really a question of qualification most of the time, but it's we don't have a precise selection process. That's a little bit the problem that I'm seeing. That the most qualified students don't always get into doing research. So it's most of the time, at least in my case, it was most of the time that one of the next students that came in when I had a free spot. It's sad that it is like that, but we don't have like a library or an official application system how students could get involved with research. My personal advice would be for any of you, try to sneak in through the back door. It means to the graduate students first. If one of my graduate students came to me and said like, hey, listen, there's this undergraduate who wants to work with me. I think he's great, or she's great, and we get along very well, and they're interested in the research that I'm doing. I have this project carved out. There's no way for me to say no. So there's absolutely no way. So if you get in contact with the graduate students, that's a much easier way in. Plus, you actually get the choice. I mean, usually if you go to the faculty themselves, they're going to assign you a graduate student mentor or something like that. And here you actually have the opportunity to actively pick a research project that you might be interested in. So one way of doing this is, for example, what do they call the second year presentations for graduate students?
Oh yeah, the GRS.
Yeah, the GRS. Go to the GRS. And people present their research that they did during the first year and a half or something like that. And if you see something that you're really interested in, you should basically just grab that person after a talk and say like, listen, I really like what you're doing. Is there any chance that I could work in the lab with you or something? I think that's a much easier way to get into the system. Because I have to be really honest about that. I get roughly 20 applications from undergraduate students per week. And it's really difficult to, A, to keep track of that, and B, it's again the space issue. Basically I'm forced to pick the one that is closest to when the space opens. So it's a kind of a lucky shot, and it's unfortunate that it is that way, because many people have been waiting to get these positions for a long time. And the problem is just that there's not enough spaces in the department usually. So try the way with the grad students.
I
It's
recommend that
much
for
easier.
grad students too.
It's much easier.
For the research that I'm doing specifically, the lab development, we have, because of this system being a little bit frustrating as far as not knowing when space is available and that sort of thing. I tried out for the first time this semester using the URAP program, the Undergraduate Research Apprenticeship Program, and that worked pretty well for me because my work is done on a very kind of clearly defined semester basis. But I think one of the reasons that a lot of the faculty members don't use it is because it's not the start of this semester or the start of the next semester when the spaces open up. So I think it depends a little bit on the type of research and that sort of thing. But highly recommend putting an emphasis on networking with graduate students. Talk to the GSIs for your classes and ask them to introduce you to somebody, because they all know each other.
Yeah, there's maybe something else to mention. There's the idea floating around in the department. We're trying to implement that. There's kind of a home page or something where you can send in your applications if you want to do research, and basically the faculty can then go onto this homepage if they have an open position, basically go through your CV and pick the people that they think fit the best. That is going to be a little bit more competitive for you guys, yeah. Because then there's going to be a pool of, I don't know, 50 undergraduate students who want to do research. I've also realized that sometimes it's a little bit difficult to decide whether to take a graduate student who is a master, who goes for a master in chemistry, or for a bachelor in chemistry, or from other disciplines, because I get applications from everywhere, so from biochemistry, from biology, even though I'm not doing any biology at all, so it's kind of like a mail that probably gets sent out to all the faculty. So this is a little bit difficult. We are working on a model system that will implement something like that, but it's not in place yet. And I still think the best way is basically, as you said, to talk to the teaching assistants or something like that. And all the graduate students know each other, so it's usually the easiest way to get into research.
Yeah, so I have to agree with both of you. We get a lot of applications, really large amount, right? I actually have a very nice boss, so he pretty much lets grad students and postdocs pick their own undergrads. If you're fine with it, it's fine. So definitely try to talk to grad students and postdocs. And so I had about 20 applications last semester that was sent to me that I thought might be a good fit, and I ended up picking one person, and so this is advice to help you kind of try to stand out. Try to read about the research that that grad student or postdocs do. Spend some time and truly know whether this is something that you want to do. Research takes long hours. So you get in at 6 and leave at 9. So that pretty much I don't get in at 6, but I do spend at least 12, 13-hour days. A lot of undergrads spend long hours in the lab. So if I see that somebody is really passionate about research and they're excited, they're motivated, that is certainly a plus. And that was what kind of helped me to work with undergraduate students that I'm working with.
One last piece of advice with regards to networking with graduate students. When you're in a class and you have a graduate student who's teaching that your lab section, for example, one of the things that can really make you stand out from the other people who are in your class is if you're asking questions that really reveal your curiosity about the subject, either the subject that's being studied in the lecture or in that particular lab experiment, or something even that's only tangentially related. Something that really lets your curiosity about science show, as opposed to, why did I get 2 points off for this thing? Because the first thing that the grad students really get tired of really quickly is dealing with it. They don't like grading. They don't like taking points off your lab reports. They have to do it. It's their job. So to stand out from everybody else and make yourself be somebody who they would say, oh, I would really like to work with that person. Be that person who asks the interesting questions.
And you can always go on different labs and websites. Usually there's a brief description of what grad students and postdocs do, and you can find their publications easily. Just don't expect to understand everything, but if you somehow can show the grad student or the postdoc that you have tried, you kind of understand the basics of the research, and that's something that really fascinates you and you're passionate about it and you're willing to work hard to learn something, then you will most likely get it.
So, what aspects of your job are most appealing to you?
Okay, so most appealing, I already talked about this. It's really the learning experience and being a part of something, and that not a whole lot of people send in your paper, usually, as you guys know, everything is peer reviewed, so there are a number of reviewers that look at your study. Sometimes they have really good points. They are constructive comments that you embrace. You don't want to publish something and that is questionable. But a lot of times you have to deal with the politics, you have to deal with people that just like rejecting things. And that could take 6 months or a year of your time answering one question that a reviewer asked. And your PI or other co-workers can agree with you that it's completely not necessary or it's just time consuming, but to publish your work, that's what you have to do. So I guess that's the least appealing part of doing science. I guess you have to deal with that with grants, so that's even worse.
Don't take it personally.
I would say that my favorite part of my job is office hours, and I'm kind of sad there's not very many people coming to office hours this semester. I think it's at a bad time. I think that the thing that still gets me excited is when I can identify where somebody is struggling with understanding something and find a way to explain it, and by the time I leave, they get it. Like that's the thing about my job that I love. And that happens in office hours and also sometimes in lecture. The least appealing part is probably dealing with grading concerns. I would love to teach a class where I didn't have to assign grades.
Well, for me, I guess the most appealing part is actually interaction with, it's going to sound weird when I say this now, but it's with young people. So basically your level, so undergraduate students and graduate students, and basically see them develop over time, whether it's in a course that I'm teaching or whether it's in the lab itself. It's very interesting for me to interact with them in this environment of science and to solve scientific questions and see them basically. So in courses, for example, the one that I'm teaching right now is an advanced course in physical organic chemistry, at least that's what it's called. And it's kind of one of the first courses where you actually start explaining to undergraduate students how chemistry really works. So in the first 2 or 3 semesters, it's basically you get concepts or you get models with which you explain some basic stuff or that work for basic stuff. And this advanced course is the first one where you actually go in depth into things and explain fundamentally why things are the way they are. And it's usually the first 2 weeks. The students are very, very confused and very apprehensive about pushing away these basic theories that they learned in the beginning in the first 3 semesters or so. But once they get over this barrier, they suddenly realize that now I can finally explain why in this case it is this way, and in this other case it looks very similar, it's not. And this is kind of the point where the teaching part is very exciting for me, and that's why I love this course so much. The thing that I like the least, I have a lot of paperwork piling up on my desk. And the thing that I like the least is, if I come to work in the morning and I leave at the end of the day, and I have to look back on what I've done the entire day, and it's been just basically reviewing papers or signing this, signing that, organizing this, organizing that. And I did not have time to go through the lab and talk to my grad student, just to hear what's going on, if that experiment worked or not. And this is a little bit frustrating for me, because that's basically the reason why I went into this job. And if I have days or several days in a week where I can't do that, it gets a little bit tiring. I mean, you get sick of it. And then the pile on my desk rises for another week until I go back and work on that. So that's a little bit the thing that I don't like that much. And it's not something specific, it's basically just that your responsibilities are taken away from the stuff that you really like, which is doing research and this interactive process of doing research with your graduate students and postdocs. And if that's taken away from you because you have to fill out 200 pages of safety requirements, that's a little bit long.
What is one of the hardest parts of your job?
Patience is always, not always, but sometimes hard to hang on to. Just as we all mentioned, you really have to be patient with others to be successful. So that can sometimes be hard. And again, there are times when I convince myself that I'm an engineer at heart and I should go back to problem solving and abandon biology. There are other times that I should be loving. So hanging on to that patience is important.
I think that I still have ways to go on time management. There's some things that I look back at the end of the day and I'm like, that should not have taken me 4 hours to do that task. It's because I've been letting myself get distracted by 3 other things that I was more interested in doing. Ended up having to stay really late to finish the thing I didn't want to do. So a little bit of time management is probably the thing that is challenging right now.
I think, and I'm not saying that as a faculty, but I'm saying that basically on the basis of as career in science. I think the most difficult thing, or in order to survive in that business, you have to develop a way to cope with this roller coaster of emotions. Yeah. And if you're really passionate about what you do, you want it to work. And many more times it does not work than it does work. Yeah. I can give you an example. One of my grad students told me yesterday that they had crystals and they wanted to measure the X-ray diffractions of those crystals so to actually see the molecule itself. Yeah. And they were excited about that the entire last week, and it was a very important molecule. And they went into the X-ray diffraction facility yesterday, and they spent 5 hours on the instrument, and it just did not give enough data so that you could solve the structure. It was missing like a lot, like 70%. Yeah. So that is frustrating. That is really, really frustrating. And you have to develop mechanisms to cope with that. To basically be able, basically not to go home and be like, this is terrible, I never want to go back to work, but basically to have a mechanism so that you go back and say like, okay, screw this, it didn't work today, I'll try it again tomorrow, and ultimately you're going to succeed. Yeah, ultimately, persistence prevails in that case. But you have to develop mechanisms, and this is mostly a psychological thing, to be able to deal with that. Yeah. And I think this is one of the most important steps, or that you learn during your first years as a graduate student, sometimes first months as a graduate student. That it's not like you're basically taught in class, you draw a reaction on the chalkboard and it looks perfect, 100% yield. That's never the case. Those are very, very specific examples that you find in textbooks. And they are put in textbooks mostly because they look good. They do not always reflect reality. If you have a textbook reaction, it does not apply to all substrates. So it might be a great idea, it might look great on paper, but in reality it doesn't work. And this is the connection that you have to build at some point. Something that you learn actually if you do research as an undergraduate in a lab. You're exposed to that. Yeah? So if you try to synthesize a molecule specifically, one way to get there is never enough. If you want to synthesize a molecule, you have to at least come up with 3 or 5 different ways, because you can be sure that the first one is probably not going to work. Very likely not going to work. So you have to be aware of that, and this is something that you just have to develop your own methods and your own tools to cope with that. It's part of science. On the other hand side, then you have to develop other methods to savor these few moments where things actually work. So when we have a big thing in our lab, or if we had had the crystal structure, for example, we would have all gone out for dinner and for drinks. Because, I mean, you have to celebrate something like that. It doesn't happen very often, but if it happens, you really have a reason to go out. So.
So what types of students do you take as undergraduate researchers?
Yeah,
In more detail?
I think, and I can just kind of emphasize again what I think is really important. I think you guys are all very intelligent. You're fully capable of learning new skills and new things. And what I value the most is the passion for research and curiosity and the willingness to learn and put in the hours. So those are, if somebody comes in to my office and can express all those characteristics, then I most likely will not be able to say that to that person.
I think that the majority of the applications that I get are from people who I would consider qualified, so that's not really an issue. It ended up this semester coming down to did people's schedules match what we needed them to match in order to have everybody in the lab at the same time with each other and supervise. So there were a couple of people who their schedules didn't match originally, and they contacted me, with a well-timed, polite follow-up and work out a few of the differences, and I ended up taking more people than I planned to do. So being persistent and a little bit flexible in your timing was helpful, because, I mean, once you got past the qualification, like, there were a few that were just not qualified, but once you were what I considered qualified, it was that flexibility in timing.
Yeah, I basically can just summarize this again. It's for me, it's mostly a question of motivation. If I understand why you want to do research or why you want to work in my lab, it's usually never a problem to get you an open spot. It's sometimes hard to communicate that, and I have to be a little bit careful here, but it is one of the requirements if you want to go in chemistry to graduate school. You rarely ever have the chance to get into a graduate school if you haven't done undergraduate research. So in the chemistry department, we try to give people where we clearly see that they're gonna want to go to a top 20, top 30 graduate institution. We give those people usually preference. That falls in line with usually their motivation. They really know that they have to do that, and they need that in order to get into the top 20, top 30 schools. So we try to allocate these people as much as we can. There's of course there's other levels of motivation. Some undergraduates come in and say that they want to do research because it's one of the requirements to get into med school. We get that a lot. It's difficult to pick one over the other in these cases. And sometimes it's really a personal decision. I have two students who are going to go to medical school now that started last year before when I started. And I think they're brilliant. They would succeed in every graduate school in chemistry too, but their motivation is just a different one. So I think it all boils down essentially to motivation. If you want to go into med school, you have many more opportunities in a very diverse field of scientific fields. If you want to go to grad school in chemistry, you're essentially restricted to do chemistry undergraduate research because the institutions will otherwise not admit you. So we try to balance that as much as we can. This is kind of the motivation from our side.
How closely related is your undergraduate research and graduate research compared to research? Because, like, is it a similar
What I did my
type
undergraduate
of project?
research,
Yeah. Do you focus on the same thing that you focus on grad school?
So what I did, the research that I'm doing as a faculty right now, how is that related to my undergraduate research?
Yeah, did you like continue your project, or did you start something completely?
No, it's actually a freak coincidence that one of the molecules that I made in my undergrad studies has showed up in my research again now. But that's an exception. Usually it's totally different. There's too many years between them. In my case, it's 7.5 years between what I did in my undergrad and what I'm doing right now. Certainly, I mean, you build on the experience that you gained throughout these years, yes. But the program that I'm running now has essentially nothing to do with what I did in my undergrad or what I did in my grad studies, well, it has a little bit to do with what I did during my postdoc. But they do not immediately overlap. It's not that you basically take this project on for the rest of your life. So I would see undergraduate research essentially as a basic environment where you learn the tools of the trade. Yeah? And I think most of the time it's not even that important which specific project that you're working on, but it's basically to learn how to do research, how to be precise, how to interpret things. Yeah, basically to learn the tools of the trade. That's the important part in undergraduate research. And of course, it's much more exciting for you if it's a project that you really like and that you're interested in. Of course, I mean, that's why you have a chance to pick usually. That's why I tell you, look among the graduate students, find something that you're interested in. But I think the outcome of undergraduate research is definitely not that you're going to keep on doing or keep on working in the same field forever. Like the graduate students that I have, for example, they did undergraduate research in totally different things. So that's absolutely unrelated to what they're doing right now.
My undergraduate work was also not at all related to my graduate work. So I probably really couldn't even give you a cohesive scheme of what I was doing as an undergraduate, to be honest. I tried really hard to understand it then, but there was a lot that went over my head at that point in time. And the things that I did learn that were important were more about the techniques and more about the way you approach problems than it was about the actual science that I was doing.
Yeah, same here. My undergrad was in chemical engineering. It was process engineering. That's what I majored in. And it's completely unrelated to what I do today. I did kind of form a fairly strict vision in grad school about what I wanted to do. So that's how I chose my postdoc. So I did neuroscience and neurobiology, and then I am doing exactly the same things that I did in grad school. I've just tried to advance that with incorporating biomaterials and trying to solve some of the problems. But yeah, no, completely unrelated. But I have to agree with you that it is really a growing experience. You develop so much as a person, and you can't really say that it's completely unrelated. You could have learned things in your undergrad that help you become who you are today. But from a scientific field point of view, no.
I think it gives you the opportunity to have a running start when you go to grad school. So I can see with the graduate students that I have right now, some of them did a year of undergraduate research before they went to grad school, and they had a much easier start. They knew right away how the process works, what they have to do basically, and that's something that you basically should take away from undergraduate research. The advantage of basically not having to learn these things when you show up at the university in the first weeks of grad school. You're going to be busy with so many other things at that time that you don't want to have that extra load on you. So that's definitely something different.
Along the same lines, there was, while I was a graduate student, I had 2 or 3 different undergraduates who worked with me. And I would say that none of them really accomplished much in the first semester that they were doing anything in the lab, and that was fine, that was expected. So if you're looking for a position, being willing to commit to doing more than just 1 semester is really pretty important, because you get a lot more out of it, and the person that you're working with gets a lot more out of it if it's a longer term thing than just 1 semester. And that carries over to it influences how you're doing in grad school.
So we have one final question before we open up the panel to the audience. So what is some advice you would give to these students?
Okay, so I think an important advice that I wish that someone had maybe given me is to look a step ahead and try to talk to people if you're determined to do something in life and you want to do chemistry, you want to do organic chemistry, you want to do neurobiology, and talk to more senior people and ask them to share some of their experiences with you. And if you don't want to go through something in life that takes you a number of years and then discover that, oh, this is absolutely not what I want to do. Now, that's not the end of the world. A lot of people do that and they're successful and they live happy lives, but I personally believe that if you do look a step ahead and you try to talk to people, interact with people that are more senior in the same field, you might actually gain insight to a lot of important information.
Yeah, that's, I mean, I'm not sure what to add to that. In terms of, most of you are in your freshman or sophomore years, is that right? How many of you are past your sophomore year? Some of you. So one of the things that if I could go back and do undergrad differently, I would have gotten involved in research sooner. So that's one of the things. But yeah, I think finding somebody who can kind of be a mentor to you, whether it's somebody you're doing whether it's somebody that you're actually doing research with or not, is kind of irrelevant. It's more a matter of finding somebody who can offer you advice on particular topics as they come up. So whether you're choosing to look at, looking for jobs after you graduate, or whether you're choosing to look at graduate schools or medical schools or some other profession, identifying people who have been through that process, whether they ended up in the career that you want or not, even if they're just a year ahead of you, they have a lot of advice to offer. So not passing on that.
It's difficult. There's a lot of advice that one could give you. I think one of the important things that you should keep in mind that the time here at Berkeley is not forever. Yeah? I know that you guys are certainly enjoying college life. That's all right. But be aware that there is a point, and it comes sooner than you actually most of the time think, that this is an end. And if you then start thinking about what you're going to do afterwards, it's usually a little bit too late. There's deadlines for applications to graduate schools, for example. There's certain tests that you have to pass along the way in order to be admitted. To prepare an application package for graduate school, it takes a significant amount of time. Usually they expect like 3 or 4 letters or something like that. Then you have to get the letters of recommendation. So you have to, I don't want to say that it's scary or anything like that, but I think you guys should keep that in mind, at least in the back of your head, that this is, you have to think of that on time, and you have to think of that early. Along these lines, I think one thing that is here in the system in the United States is that people decide very late in their undergraduate career what they really want to do. So most of the first year or two, people are still jumping between fields, and they only focus essentially after those first 2 years. Most of the people. And this is an additional challenge because if you decide that late, you really have to cross much higher barriers to get into the research group than if you start right away from the beginning and you try to get in early, and you can afford waiting for half a year or a year. If you suddenly see the deadline of your graduation ahead of you and you say, oh, I have not spent a year in research, and it's only 9 months left, and you're hell-bound to getting a research position somewhere, it might get difficult. And that's with many things like that, so keep that in mind.
If you just have a few months left, I mean, for you to actually get a research position in the lab will become increasingly difficult.
Yeah.
Just because projects take years. So I, as a postdoc, am not willing to take on a graduate student and train them for 2-3 months, to have them work with me for 2-3 months and then graduate.
Yeah,
So
no,
that's something to keep in mind as well. You want to start early, you want to give the people in the lab a chance to train you and mentor you, and so that you can truly learn something and learn more.
Be open enough to approach people, just get in contact with them after classes, office hours. There's so many opportunities. You're given so many opportunities here to interact with the faculty or graduate students that it should never turn into a problem. If you really want a research, undergraduate research position, it should never really turn into a problem to get one. It's just a question of how persistent you are. And I'm not saying you guys should be creepy. I'm saying what I'm saying is you guys should be persistent in the sense that when you're interested in something, follow up on this. Like if I'm saying this openly, if an undergrad student comes to my office and says, I want to work for you, the first thing I do is usually send him around the lab to the graduate students. And then if I hear back from one of the graduate students that this is a very really motivated person and they're really interested, that's the time when I actually contact that student again. Yeah. So the question is here basically, you have to show a high level of initiative and motivation to get into that. It's not difficult if you know how to do it, yeah. But you just have to show this motivation, because that's essentially